So next up, Wido.
Okay.
Over to you.
Yeah. Well, hope you had some good lunch. So I'm going to be talking with you about reusing old hardware within CloudStack and saving you money and saving the environment. So, because it's a hot topic nowadays, environmental things, but also, saving money. Why shouldn't you do it? So, before we get started, a bit about me for you who don't know me. Wido, I'm from the Netherlands. I got 2 kids, married with my wife. We had a photo shoot 2 weeks ago when our youngest one became 1, so I thought I'd put that picture in here. I've been active in the hosting industry since 2003, started my own company in 2004, which was acquired in 2018, and now that was rebranded to Your Online, the whole group, and starting in March this year, the CTO position within the group was created, and I'm now CTO of this group. But I'm still an open source enthusiast, work a lot with Ceph, with CloudStack, IPv6. That's the stuff you'll see me doing online within open source communities, but also within our group. A bit about the group. We have businesses in Spain, France and Netherlands. We're now about 1 million customers, 600 employees. So I do travel around a lot between our offices, our locations. You might find some big brands. A recent acquisition was Gandhi in France, a big acquisition which we did in Paris. So I've been visiting our office in Paris quite often recently, which is also fun. But our brands use CloudStack a lot and open source a lot. And you'll see that in Amsterdam and in Valencia, we have 2 large deployments. And I'm bringing out the voice of CloudStack in the company because we also have a focus on using open source technologies for building our infrastructure. But I must say, we also have VMware without CloudStack because it just came with the acquisitions we did. But as I said, the Netherlands, Amsterdam, Haarlem. I was just talking with somebody who liked Haarlem. Well, we have CloudStack running on Haarlem, so another reason to go there. It feels like being home when you go to that city. Now we have hundreds of hypervisors with thousands of virtual machines running, mainly for our own infrastructure. We have customers renting VPSs, but the majority is running our own virtual machines for our own infrastructure, and that's our use case for CloudStack. But to run CloudStack, you need hardware, and I don't like throwing away functioning hardware. I think nobody does because it's a waste of money, it's a waste of resources, and waste of resources, financial resources, but also resources from an ecological perspective. And we care about both. Actually, very interesting as well within the European Union. I know we're outside the European Union at the moment, but there's legislation coming up that by 2026, every company within the EU needs to start reporting on his CO2 emissions, indirect or direct. Even we as a company with our size, starting 2025, we need to start reporting about the amount of energy we use, how much CO2 we produced. And this goes further the coming years that you need to know the whole product life cycle. If you're using services, what the impact, your environmental impact of your company is. So this is something to get prepared for, and this talk might get you interested. So you're using hardware and everybody tells you 5 years, that's old hardware, you need to discard it. Because that's what HP tells you, Dell tells you, Supermicro, or somebody else tells you. It's 5 years old, you need to replace it. And in financial, we deprecate hardware in 5 years. But is it truly end of life after 5 years? And if you ask some technicians, they'll say yes, because there's no longer any support on that hardware. And I find this kind of a lame and easy excuse to say it's no longer supported, discard it. But do you actually know what you're doing with discarding the hardware? I'll get to that in a moment. But when you say 5 years, I usually say they operate for about 4 years. So you acquire them, the moment you get the machines, that's when the support contract starts running, but it takes you about 6 months to get them unpacked, installed in the rack, do all the testing, installations, move the workload, and then afterwards, 6 months before they get of life, you start discarding them. So they have an actual lifespan of about 4 years, which is quite short. 4 years, did you know you were doing 4 years ago? It was just before Corona was getting started. That's where you was with your life. And that feels like yesterday. Well, for me, it feels like yesterday. But if we're looking at environmental impact, you have a global warming potential. You have a carbon dioxide equivalent, which is usually called CO2 equivalent. And you also have a product carbon footprint. And you might be asking yourself, we're at a CloudStack talk, right? When I'm talking about environmental stuff. I'll get there in a moment because these two are connected with each other. So let's go to a Dell server. You take a Dell server running for 4 years, operational with 24/7. This produces about 9 metric tons of CO2 emissions in its 4-year lifetime. Well, you can calculate how many kilometers or miles you can drive your car for just a single machine. And I was quite stunned when I was looking up these numbers and doing some investigation. I did this research for a recent Cephalacon conference together with another company, and I took these numbers. We just took this from Dell, from the life cycle assessment from Dell, and then you just add some SSDs in there and you'll get the total impact which a single machine makes. Dell has this life cycle assessment. This is from a newer generation, but you can see that the manufacturing process is more than a metric ton of CO2 just for manufacturing a machine, and then the rest is in consumption. Now you say, oh, these numbers are reaching 6,000 kilograms, not the 9,000. That is correct, because I took this graph from a presentation from Dell. They're just using 2 simple hard drives in the machine. That's what they're doing in this assessment. Now, if you look at machines we would be using in a typical cloud deployment, let's take the Lin store, for example, where you have hyperconverged. So you have SSDs in the machine, and then you have the CPU. So this would be a realistic machine you could use with Lin store with 8 times 3.4 terabyte locally, ZFS on there, use DRBD. This could be a proper hypervisor you would be using within a CloudStack environment. Actually, 12 times 32 gigs, you might even put in more memory on that machine. So the total impact for that machine would even be higher.
As a percentage, do you think that would be use and manufacture, or would you throw out that 8.6?
8.6, I'll get there in a moment. That's my next slide. So we looked into this. Then at a 4-year life cycle, it's about 50-50. So manufacturing is 50%, and then the influence, that's how you run it the longer you run it. So if you start running a machine for 5 years, 6 years, 7 years, the manufacturing becomes less of a percentage because electricity takes over. Now, so this is our part of influence, keeping the machine running. This is the part we do not have any influence, manufacturing of the machine. But how's that built up? Taking that Dell machine I just shown you, 80% is SSD, which is the worst of manufacturing for our machines. Because the machine itself is just metal, some plastic, then there's the motherboard, which is mainly plastic and some components. But I was also quite surprised to find this out, that SSDs have a very high environmental impact when producing them. Creating those chips for the SSDs, they're very, very tight and compact chips, super CO2 intensive to produce them. And especially if you have machines with more and more SSDs in there, the impact might even go over the 80% of a single machine. So we don't have a lot of influence there, but it is quite interesting to see that there is a very high impact with hardware. Now the other 50% does depend on the country which you're in. So I looked at the European Environmental Agency. They have these statistics about how countries actually, how much kilowatt hour, how much CO2 emissions you get from a kilowatt hour. Well, the Netherlands is not doing very well, my home country, but you can check this on the European website where you can see. So it might vary per country where you are, depending on the emissions. So France is doing much better because they have a lot of nuclear power. Germany and Netherlands, we still have a lot of coal-fired plants, so that's a high impact on CO2. So using refurbished machines is a no-go, right? Everybody tells you need to buy new machines. None of the technicians would ever say, yeah, let's buy refurbished because it's better for the environment. No, they usually say, I want new machines. I want the new shiny stuff with the newest features, newest CPUs, because that's what I want. That's the most interesting, because we probably never think about the environment and impact of a new machine. But my personal experience has told me that sometimes using older machines from 2-3 years older, they are actually more stable, more reliable than buying new machines. You have somebody else doing all the battle testing of the software, of the firmware, the BIOS, everything, microcode for the CPU. It has all been tested by somebody else and not your production environment. And you save 50% on the CO2 equivalent because you simply skip the manufacturing of that machine. And it's also a significant reduction on your capex, your capital expenses of your company. You can usually see it about 50 to 30% or 30 to 50% depending on what you want to buy. So this was a CloudStack doc, right? Let's switch to the CloudStack stuff. What does it have to do with CloudStack? Well, you can do some very interesting things with CloudStack with the host tagging and service offerings. And I'm going to tell you a bit on how we did this and how we are using CloudStack this way. Tag your hosts with, and then target those hosts with your service offerings. So you can create different categories for different performance applications of your host and your service offerings. We acquire a lot of companies. We acquired about 42 companies in the last few years. So we have a lot of hardware coming from those companies. And it would be very easy to say, let's just buy new hardware, move all the resources, and then just get rid of all the old hardware. But is it always really needed? Not per se. So it's a win-win situation again. It's a financial incentive to keep using old hardware, but also an environmental win to keep using it. So we have a lot of generations of the Intel Xeon, the E5, the version 4 and version 3, so the broad one as well. Scalable, and then the AMD Epic, a couple of generations. We're not using the newest generation yet in the environment. So what did we do with our service offerings? We created tiers within the service offerings. So the tier 1, the fastest VMs, they are going to be using the latest generation hardware. So the host will be tagged with the tag T1. Then we have a subcategory, AMD Epic or Xeon Scalable T1A, T1B, because it's tier 1A and tier 1B. If you want to create a service offering which specifically targets AMD Epic because you really want that, you can then target T1A. Same goes for the Scalable. And then we have a couple of tiers. We go into 3 at the moment. You might even introduce more. You go to C or D at a subcategory, but we create these generations of.
Do you retag each year?
Well, we started with this about 9 months ago, so we haven't started retagging yet. But it could be that we say in tier 1 we're going to be removing the Gen 1 AMD Epics and then introducing Gen 3 AMD Epics, just getting those machines in with those tags and then slowly just removing the tags from the existing hypervisors and then migrate the resources if needed. But that is the plan indeed, to start retagging at some point. Yeah. But I wanted to find a solution where we could use the hardware still properly use the hardware and leverage CloudStack to make sure that we have applications running on guaranteed sets of hardware. So guaranteed, I mean CPU feature-wise, guaranteed on the same sets of hardware, but making sure we could use the different generations of hardware.
Do you make it clear to your users what they're getting in each tier, or do you just call them tier 1, 2, 3, 4? We're
not making it clear to everybody what exactly.
They don't know. They don't know.
Not always.
They know one's better than 3.
Yes.
Yeah.
And then you might be talking to about end customers, but we also have a lot of internal consumers. Talking about internal consumers, they would always say, I want AMD Epic. That's what they will always say. I want the fastest CPU out there. If you start benchmarking, you'll find that many applications do not really benefit from always having the fastest CPU. You can do some synthetic benchmarking, and it might show that you'll have a 10-15% gain, but if you look at overall real-world performance, many more things influence the performance of the end application. So just not being, I would say, honest, but not telling everybody, it's not always needed to tell everybody what they're really getting, as long as the end service is delivered the way it should be delivered. So that's what counts. So indeed, we have the T1 performance service offering. It simply targets hosts with the tag T1, and it could either be the AMD Epic or the Intel Xeon Scalable. And yeah, we might be reviewing every year, Dan, to see if this is still fit to be in the tier 1, yes or no, or it needs to move to tier 2. Now there's a thing about this is that we say, usually high performance websites or the e-commerce, they run on tier 1. Back office applications can run on tier 2, but spam filters, they can run on tier 2 and tier 3. It doesn't matter if an email takes 2 or 3 seconds more to be delivered, while running on tier 3, and tier 1 could have done it a few seconds faster. nobody really cares about that delivery time of the email because it's asynchronous anyway. If it would be minutes of delay, it's a problem, but even 5 to 10 seconds of difference, it's not a really big deal of delivery of the emails. So we can really use the previous generations of hardware by using them for other applications than just the end user serving. And there's many other things you can use, you can think about, which can run on older generations of hardware and don't really require the newest one. So we try to use hardware as long as possible within our data centers. But in the end, the uptime of the services is something which of course needs to be okay. So of course we monitor the hardware with Zabbix. We do all kinds of stuff, getting metrics out of them, making sure it still works. We update them to the latest BIOSes, latest operating systems, so they're updated and they need to deliver reliably. But we've seen recently actually that a lot of the modern machines fail a lot more than the older machines do. I don't know what's been happening for the last 2 years, but Dell and Supermicro, we have a lot of issues with the recent machines. We're not sure yet what it is, but that's something maybe.
Do you take into consideration the kilowatt hour per performance, the power usage?
No.
Because sometimes we're using refurbished hardware for years now and we're totally fine with that. We counter the support argument with we're just buying code standbys and we have the hardware there if needed, and it's much less expensive than buying support. But we did some calculation and sometimes it makes sense to get newer hardware because of the power consumption per performance.
Yeah.
Because kilowatt hour in Germany is so much expensive.
I do agree, things have changed a bit, but if you go back to the 50% of influence, the new hardware might save you 20% maybe on performance of kilowatt hours. It doesn't really offset the CO2, so it's something else. We always take the financial things into consideration, but do we maybe also need to take into account the other, the environmental impact of getting new hardware? And this is not about telling you what you need to do. I just want to bring some insights into these numbers. It's something to take into consideration when you say, shall we replace these servers? It's an interesting fact to know. I've taken one of our data centers as an example in Amsterdam. So we have a rack with in the Epic Gen 1, the Supermicros, and then all that stuff you can read it yourself. We make sure that we have the same types of hardware in the same rack. So it's not a mixture of different hardware, so one rack is identical with hardware, it's one cluster inside CloudStack. So we know that a single cluster always has the same resources, the same performance characteristics as the others ones we have. We're usually limited to 5 kilowatts per rack, so that's why you might see 11 to 18 machines in a rack while they're bigger. It's just a power restriction in the racks. So that's why it's usually 6 kilowatts is theoretical, but then 5 kilowatts practical, what you can use in the rack. Now, things you need to take into consideration within libvirt or the CloudStack agent is making sure it programs libvirt properly, setting the right CPU model. So you might set AMD Epic IBPB, I don't know what the acronym is anymore, but that's something within libvirt. Or set it to the Broadwell IBRS, making sure that the CPU flags match. You can do live migrations between those hosts. If you do not set this, then even the slightest change within the CPUs could also prevent you from doing a live migration. So make sure you actually set this properly. And then it's the HDMI, which is not the best. Some of the racks, so we try to keep the hardware exactly the same in the rack. So these are some Dell machines. These are also some Dell machines, but different types of hardware, but identical hardware in the same rack. Now, interesting what you said about the kilowatt hours. I was thinking about putting a slide in there. Is that let's go back, with us as engineers. It might be interesting for the project for CloudStack to at some point figure out whenever somebody opens a pull request and our whole CI/CD starts running, and somebody says, please retest this single line of commit, and we start building CloudStack completely. What is the impact of a single user telling the CI/CD to do a complete build and packages and testing, whole test suite of CloudStack? What's the impact? I don't know. I know what the impact is, but it's quite interesting that we are going to this continuous development, and we hold the CI/CD running in all these companies, just firing containers and doing a complete build and discarding it again when they do one line of change. So how much has the impact become of development and GitHub with the CI/CD or GitLab running internally with somebody? I don't know, but I think it's quite an interesting thing to think about, how much of an impact environmentally it has on electricity consumption. if we can calculate how many kilowatt hours are being used for a single CI/CD job, and I think it goes beyond the kilowatt hour, you can actually figure out how much CO2 we actually emit from changing a single commit or single line, which might even be a comment, and we do complete build and testing. And I think nobody's really doing this, or maybe it's time to get these conversations started, but it is an impact. And again, this is, yeah.
Can I suggest that it's not only CI/CD, it's all kinds of workloads would benefit from power metering?
I think, yeah, and I think this European legislation will at some point also make it mandatory for companies to start looking into this. But CI/CD, because it's pretty close to open source projects, we don't think about it. We just say to the CI/CD, do a test for me, and machine starts crunching somewhere, and you get a result, and you're like, I made a parse error, there's a compile error, I made a mistake, run it again, run it again. Yeah.
It's like trying to teach teenagers to turn the lights off.
Yeah, yeah. So, but you know, what's worse, keeping the lights on in house for a night, or running one CI/CD job for CloudStack? I honestly don't know. But I kind of guess that leaving the lights on is better than running that single CI/CD job. I kind of have that.
If you're using old files.
Yeah, an LED. I know. But this is no. With this talks, I'm trying to create a bit of awareness of that, and this is mainly the message I wanna give. Is this one? So, hardware production has a significant impact on the environment. It is usually not known. It's underestimated. It has a significant impact. Older hardware can be used, and please make sure that when somebody tells you, no, you need to discard it after 5 years, it's old, or somebody says we need to buy new, think twice. Please think twice before you make a decision to discard hardware, to throw it away. Sometimes just upgrading everything to the latest versions of the firmwares, everything, dusting them off, putting them in a rack again, recabling, just making it look nice and shiny, and it's good to go again. So think twice before you replace hardware, because it has a significant impact, and by reusing the hardware, actually your CO2 budget is not impacted, and it's probably also good for the financial for the company. So that's mainly the thing I wanted to convey, and everybody started thinking about it. So it's not something you need to do. Think about it, start thinking about it, and have a talk about this at the office with your colleagues. And that was mainly it.
Any more questions, Wido?
What do you do when you're adding capacity? Do you go out and buy a load refurbished and a load new, or just new and then everything has to shuffle down?
We buy refurbished and we buy new. So depending on which cluster is getting short on resources, we might expand that cluster or then build a new cluster with the same resources, depending on where the workload requirements are. But we do buy a lot of refurbished hardware.
Do you have a problem with the reliability of it? Because 90-something% of problems we have in CloudStack is a DIMM going bad in old hardware and crashing the thing.
No, we have a good supplier which does the testing for us before we receive it, and I must say that they're doing a really good job. Recently, as I just said, we have been seeing, and recently I mean in the last 2 years, much more problems with newer delivered hardware, and I mean major problems with new hardware. We would send 30% back to Dell again because it was just broken, dead on arrival, than compared with refurbished. So I think it really depends on your personal experience. Yeah.
In your experience, what is the lifetime of an SSD?
An SSD.
SSD, sorry, yeah.
I see them fail earlier than actually the wear level indicators says they should fail. So sometimes they just die. But yeah, we have SSDs which have been running for 5, 6 years, 7 years, and others die within 6 months. So I wouldn't say they are much more reliable than hard drives.
Did you take that into account in the 80% you just showed?
No, that's just the manufacturing. So that's just manufacturing the machine.
So that's assuming the whole machine runs for 4 years minimum.
Yeah. If you start replacing SSDs in the middle, your impact will be even worse from the manufacturing perspective. Yeah.
What's your oldest machine now in production, would you say?
7 to 8 years.
Okay.
And routers to switches go even up to 10 years. Or even beyond 10 years. Yeah.
On the networking side, do you keep it homogeneous across all the tiers or different bandwidths?
So usually if we would go to this 25 gig, 10 gig, 25, 25, 25, 10 gig, 10 gig. So the top of rack would run 10 gig, and if it's a 25 gig, then the uplink to the spine would be 100 gig, otherwise the uplink would be 40 gig, because that's depending on the chipset and the switches. And networking wise, we're using VXLAN everywhere with BGP and EVPN. So in theory, any VM can run on any of the nodes, because BGP will just make sure you can start the VM there. And we're using Ceph storage. The Ceph storage is not connected to a single cluster, it's a zone-wide storage. It's routable, reachable by every hypervisor, so any VM can run anywhere. So I recommend you watching one of my talks about VXLAN and EVPN, because that's a great combination with CloudStack. Yeah, one more question.
You mentioned previously about the carbon footprint. What's the difference between a refurbished product and the new one? How would you evaluate the difference?
Well, if I get your question right, the difference between a new and from efficiency perspective is difficult, but of course if you buy refurbished, it has been produced already, so you're giving it a second life instead of discarding it, going through the shredder, because that's what happens a lot of times with the hardware. So there, of course, the impact is 100%, because it's manufactured or not manufactured. From efficiency perspective, it's a difficult calculation. But then what is efficiency? You need to determine that at first.
Just to add to that, so for example, you mentioned that 80% of the manufacturing cost of a new hardware is the SSDs. But when you're buying a refurbished server, I'm assuming you will put with new SSDs or disks in it.
Not always.
Wouldn't that?
No, I know. If you buy new SSDs in a refurbished machine, the impact is of course very different, because the SSDs have a high impact. But we very often you get back SSDs which still have a proper lifetime, which still can be used.
Yeah, but that's basically if you want to make sure that you have the reliability, and you say we want to make sure that this server that I'm buying has, or basically we want to make sure that these servers has a specific SSD, because we use that SSD all across the cluster. That, like, what's the difference there? That 20% manufacturing difference?
I haven't gone that far with the calculations, and I must say, of course, we also buy new hardware, and a lot of stuff goes into tier 1. But for example, these machines, the older Dells, they are using a per controller with SATA SSDs, and there might be a mixture of Samsung and Intel in there running a RAID 6 environment, and we really don't care that much. Performance is fine. They can do 10,000 IOPS on that controller, which is sufficient for most applications running on there. It's a lot of time local storage. So there's a lot of variables involved in here, and this is mainly about awareness, not about knowing all the numbers, but you can look up this, as I said, this life cycle assessment from Dell. Dell is really good with this. You can get them from all their machines, and you just get a glimpse of the impact of a single machine has. So again, the message is mainly think about before you buy new hardware. That's the main message. There was also one more remark at the.
So,
Yeah.
Up to the. So if I buy a new server, and I pay the cost of manufacturing, the kind of environmental cost of manufacturing. When I retire that server, and instead of shredding it, I sell it on the second-hand market.
That's of course the best thing
That's the best thing you can do.
That's the best thing you can do. Yeah.
Then you say, when you buy a server, you assume that the manufacturing cost is zero. So I'm wondering, like, who gets to claim the benefit of it?
Yeah. If you share it. Yeah, you can. You share it. And but you could also view it otherwise, is that instead of buying new hardware every 5 years, give it a bit of longer life cycle.
Yeah.
Use it for 6 years, for 7 years.
Yeah.
That has a major impact. And then again, no, Sven, you said, of course, about the efficiency of a CPU, modern CPU. So there's a lot of things taken into consideration there. but manufacturing has a high impact. So every year it runs longer. That's better than producing something new. And this goes against what manufacturers want, because our economy says they need to sell boxes as soon as possible. So they want you, and this is not a evil conspiracy, but this is how businesses work. They want to sell, so they want you to replace hardware every 3 years. Yeah, make your own calculations and just mainly saying, take it into consideration when replacing hardware.
And some of that stuff with the legislation that's coming along, you might end up with a lot of that will get quantified in terms of the write down of the carbon, just like financially how you write things down.
Yeah.
That will get laid out because companies will be taxed for carbon in a few years' time.
Yeah,
it's inevitable. Right?
I've been reading into this EU legislation, but it's hundreds of pages. But indeed, it will go at some point that you need to have a complete analysis of your your chain, where you buy something, what the impact is, the life cycle, and then when it leaves your company again, even if you're delivering services. But then we're looking at 2028, 2029 when it comes into action. But this is upcoming.
So, question from an EU perspective: what is the regulation like for how you can strip a drive of data and then be able to sell it without running into a compliance problem? Because in the US we can't do that. We have to pull the drives and discard them and crush them.
This is of course a GDPR thing. Honestly, I'm not a real expert on that part. I would say if it's encrypted and it's erased again there's of course those drives can also run secure erases themselves.
The problem we have in the States is the regulations 20 years behind reality, and so it shouldn't surprise anyone here. But so we have a problem with the auditors where they say you cannot sell drives. So we literally used to have just pallets and pallets and pallets of drives.
Okay.
Now we have the same problem in Germany. We have customers which are demanding to shred the drives. It doesn't matter how old they are because of GDPR, and they want to be 100% sure to be compliant with that.
Yeah, but the question then is, of course, is it really GDPR requiring it, or is the mindset of the customer?
Misunderstanding.
Yes, that's the thing. Because if it's Lux encrypted, good luck with getting any data from that drive.
Totally agree.
Yeah, but that's us technicians, right? So again, I'm going over time, so I'll leave it with that. Again, it's awareness, it's not telling you what to do.
Thank you, Wido.